Good morning to all dear students. We are going to discuss the remaining topics of electromagnetic theory. As due to the holidays, the management has decided to conduct the online classes for 2 to 3 days. Again, our offline classes will resume from Monday onwards. So we have a very less time and congested time. So due to overcome these difficulties, we are decided to conduct the online classes. So let us discuss about our remaining topics, whatever we are having in the electromagnetic theory. So the free space, how the electromagnetic waves are going to travel in the free space, we will try to discuss here. EM waves in free space. Understood? So the more detailedly we will try to discuss now also here. So what happened here? Electromagnetic waves in the free space. Understood? So the free space, we very well will know at the end what is actually the definition of free space, what stands for the free space, and how EM waves are there. We will discuss in the end of the topic. Remaining 10 minutes we will discuss about the free space definition and remaining how EM waves are going to travel. So here the entire topic is about the propagation. Propagation. What is meant by propagation? The propagation is nothing but the wave which is going from one direction to the another direction. Understood? So the wave is definitely going to travel from one axis to the another direction in the three-dimensional axis. If you try to consider in this way, what happens? Magnitude. Whatever the electric field, magnetic field is acting in the opposite direction. X-axis, Y-axis, and Z-axis. So like this, we are going to have the propagation. If it's a wave is along the x-axis, the electromagnetic wave is going to act in the forward direction. Thrust and troughs we are going to form like a sound wave. We are having here different type of photon particles moving together here. So in the propagation of free space, what will happen whenever we are trying to change any medium, definitely the velocity of the wave is going to. In this also we are having the different type of spectra. Understood? So if you try to consider an EM wave propagation, it is entirely depending on what? It is depending on the electromagnetic spectrum. Wave has a different range, depending on the wavelength. I am drawing the rough diagram here. What is happening? The wave propagation, whatever you are trying to see, the propagation of wave, what is happening here? It is going to decrease as we are moving from one direction to the another direction. So entire range, this is called what? Electromagnetic spectrum. Electromagnetic spectrum. Understood? So here we are at the amplitude. The amplitude of wave is greater, is very much more compared to the less. And here if we are trying to move, as we are moving, the amplitude goes on decreasing. Goes on decreasing. Like this it will come down. Electromagnetic wave, what is happening here? The spectrum is going to decrease as from one axis to another. And magnetic field is going to act in one direction, electric field is going to act one direction, and here entire range along the x-axis, z-axis here, and here y-axis. So like that we are going to get what now? We are going to get the total is called the electromagnetic spectrum. In this total electromagnetic spectrum, what is going to happen? We are going to generate a entire range, different range we are going to get. That is nothing but electromagnetic spectrum. And let us know what are the different type of spectra is going to explain. I will try to explain. Here, if you try to show here, we are going to get the radio waves. Radio. What are radio waves? The range is nothing but 10 power nearly 5 or 7. 10 to power 5 to 10 power 7. Again, if you try to move from radio, microwaves. Little bit amplitude is decreasing 10 power 3. And next range we are having microwave, radio waves. The radio waves having the amplitude more, that's why it can able to travel longer distance. And whereas microwaves having the lesser, cannot able to travel the longer distance. And another is called what radio waves, microwaves. The third type of wave, which are nothing but IR, infrared. Understand? Infrared also very important. And after this, another wave we are in the UV. UV. Next, we are having here visible. Like this, we are having after visible. We are going to get the different type of waves. UV, IR, visible, and we are having another wave system for X-ray. And as we are going from away from this, what happens? We are going to get the different type of wave. And last range wave is nothing but 1, 2, 3, 4, 5, 6, 7 plus is nothing but the gamma rays. Gamma. As we are going from here, what is the 10 power minus plus 1? And here 10 power minus 10 power minus. The range is between 4,000 to 7,000 ounces. As we are moving here, 10 power minus 10 power minus. Like that, the axons in the axons we are going to. Like that, what happened here, the electromagnetic entire spectrum is we are going to. And this electromagnetic waves we are going to get propagate. How it is going to propagate depending on the type of the wave. How it is going to move from one direction. In the free space, what happens is all waves are does not happen. Only few waves are going to happen. Some are going very faster, some are going very slower, depending on the amplitude. If the amplitude is very small, it can penetrate inside any material. If suppose radio waves you try to, it can travel up to very long distance. In generally, our electromagnetic theory, what happens? We are not going to consider all the electromagnetic spectrum. Only radio waves is taken into consideration, some microwaves and visible light. But gamma rays, X-rays are cannot able to penetrate inside. You please note on this diagram and propagation of wave. Then I will try to explain the free space how it is going to happen. Plus, so in this manner, we can able to understand how the propagation of free space is going to work. And at the end, what we have to do in a free space, free space means we will try to know at the end, but how it is the wave is going to propagate. And hence, we should prove that it should be equal to about 3 into 10 power 8 meter per second. 3 to 8 meter per second is the velocity of the light. It should that much. Means 1 second the light can travel in any medium. Before that, they used to think that the only electromagnetic wave. Light is not considered as an electromagnetic wave. Just general, the velocity of light is calculated. C is equal to light. As C is equal to V by lambda. We very well know C equal to V by lambda. Velocity of light increases. What happens? Definitely the frequency frequency also increases and wavelength is. So the simply we can call as the wave number is increases, definitely we are going to decrease the frequency in the opposite direction. You can able to understand. And here we will try to know detailing how the propagation of wave is going to take place. In free space, what happened? Whatever the free space we have taken, we have having the two components. Components. What are the free space components we are having? We have the components of electric field and magnetic field. What are try to know here? We are going to know. And oppositely, what happened? We are going to get the electric field and magnetic field. So both together, we are getting the spectrum. And here to here, the range between here to here is nothing but what? There is called the lambda. There is called the lambda. So entire wavelength from one point to another point, or up to here also we can call the lambda line. This is entire value is called the lambda from here to here. To take into the S about the negative direction and positive direction. So both together we are getting the electromagnetic. And here we are having the electric vector in the y-axis. Electric vector. Electric vector. And here is the direction of propagation. Direction of propagation. And here we have magnetic component. This is dotted line is what now? Magnetic component. Magnetic component. So this is called the magnetic component. So whenever you are trying to check the electric field, the magnetic component is also going to. So our target is here what we should prove that the free space, the light is moving at the what speed 3 to 10 per 8 meter per second. The velocity we should have. And from here the basic fundamental is what we should understand propagation principle. If you don't know the propagation principle, we cannot able to judge how the waves are going to move from the one direction to the another direction. And here we are having the wavelength lambda, and here is called the electric component. It's called the electric component. Electric and electric vector, electric component, direction of propagation, magnetic component, and here we have the x-axis, and here we have the z. Understood? Like that we can be able to judge how the waves are going to move from one direction to the. In this, we are having the wavelength of different values. If suppose in the free space, wavelength can be considered based on the 1 micrometer. 1 micrometer is how much? 10 power minus 6. Understood? Again, 1 nanometer. 1 nanometer. 10 power minus 9 angstroms. Understood? Or we can write directly in the meter. 10 power minus 9 and 1 angstroms. You know very well 1 angstroms. Equal to how much? 10 power minus 10 meters. So all the values we are written in what now? We are written in the form of meters. So overall we can able to know how the wavelength. So wavelength is in the free space. In free space is calculated in the form of 1, 2, 3 like this. 1 micrometer, 1 nanometer, and 1 angstrom. Like this, the different propagation of waves is going to return here. And hazards. Like the wavelength, whatever we are having, the free space having the frequencies. Frequencies of what? 1 hazard. Means equal to what? 1 hazard means the 1 vibration. The frequency very well know the number of vibrations are making per unit time. So 1 hazard is explained in terms of 1 cycle per second. 1 second inverse or per second we can write inverse if you go can write 1 second how many number of vibrations is doing. And like that we are having the fundamental form as a wave number. Wave number is denoted by what? Wave number. Wave number V. The V bar represent what? The V bar represent generally wave number defined as wave travel in 1 meter. That's here to here suppose we are having total V bar 1 meter. Here to here we are having 1 meter. Like this we can able to get the total. Now why we are discussing all these things, if you know this fundamental frequency, wavelength and wave number, overall we can able to get what? We can able to get the fundamental how the wave is going to travel. So now we are moving here to what? We are moving how actually the wave is going to propagate. How it is going to act in the different medium, we will try to see. So the among the target of this is what we can able to know different layers. Earth has the different three types of layers. Whenever the wave is going to form, now we will try to extend at the end this layer inside core. We are having the structure. We are not related to core. It does not take consideration. Now, south, east, west. That's true. Like that, we are going to connect. Whenever the wave is going to travel from one direction to another direction, it is going to act in a different layers. Understood? Different layers it is going to act. And some type of waves are going to come back, and sometimes it's getting disappear, and sometimes just only up to here. So why it is going to happen? Because this is a free space. Electromagnetic waves can travel in the different free space. So overall, what we have to understand and our target is here the wave. The wave is nothing but electromagnetic wave. Electromagnetic wave. This electromagnetic wave will help us to understand how the wave is going to move from one direction to another and returning back in the propagation process. Now let us more detailedly we will try to know what actually is going to happen and how the penetration is going to happen or skin depth. That is a higher topic is there. We will discuss in the next class. But my target here, I want to explain how the free space is equal to the velocity of light. C is equal to 3 to 10 power 8. So let us now try to do this. A very good morning to all dear students. We are going to discuss this today topic, that is online class. Due to the heavy rains in our city, the government has declared holidays for all the students. So in this perspective, we decided to conduct some online classes for 2 to 3 days as per the instructional management. So it's such that our syllabus can also be easily can overcome because days are very less. So here in this class, whatever the topic which were discussed in the earlier, the remaining topics what we are having in the unit 2, we are going to discuss. That is nothing but the electromagnetic radiations, how it is going to travel in the free space on an isotropic homogeneous medium. So let us try to discuss in this today topic. The topic name is electromagnetic radiations, how it is going to travel in free space homogeneous isotropic medium. So an introduction points also we will try to discuss. That's nothing but electromagnetic electromagnetic radiations in free space and isotropic isotropic medium. And dielectrics also there. I will try to explain the dielectric also. So here, if you try to understand how and what is actually with the free space. Free space. Free space is nothing but it is a combination of all the molecules and atoms which are present in the outside, or we could call it simply for surroundings. Surroundings. What is surroundings? Surroundings is nothing but the is entirely filled with what surroundings? Yeah, surroundings is nothing but the entirely it is filled with what? Filled with the particles. So the last chapter, first chapter, it is related to what Maxwell equations and how the Maxwell equations can be applied, and what is the extinction part of the Maxwell equations. But the background of free space, it is entirely depending on what? Entirely depending on the electromagnetic radiation. As we very well know, the three, four equations we should know before discuss. The first equation of the Maxwell before that what happened? We have the VD is equal to Q by epsilon naught. Gauss law of electromagnetic of closed field. Again, like this, we are having whenever you are trying to change the electric field, magnetic field will generate in the perpendicular time. Understood? So what happened? Ampere's law. You will not understand. So whenever if you are trying to say let's say Faraday law, Ampere's law, and when Maxwell came, and Maxwell came what Maxwell said, whenever you are trying to change the mu naught I plus unknown element, unknown. So what is this unknown element? Unknown element is nothing but a displacement current. Displacement current. What is displacement current? Whenever the current is continuously trying to change, this modification of Ampere's law. Ampere's law is only permitted to this. Understood? This is explain about what? It is explain about the steady current. Steady current. Understood? Steady current is what? Steady current will explain what? It will explain about the stable, no change, no change. Whereas displacement current, what more displacement? Displacement is what change. Change of E and B both. Both E and B are continuously going to change. It is called what? Electric field and magnetic field. Well, Maxwell generally explain about what more it is explain about the displacement current. Huh? D by dt. dt means rate of change of current with respect to time. Then what happens? Then we can able to understand whenever you are trying to change E, B will change, B changes, E also changes. Both are interconnected to each other. Understand? Like that, we can able to know so many things about the change of electric field and magnetic field. Can be able to. Now we will try to apply the Maxwell equations in the free space. How we can apply Maxwell equations of the free space? Let us try to do. What is free space? We have discussed. Free space is nothing but outside and surroundings. How the electromagnetics, whatever we are having, change, multiple pole, water pole. We have discussed. We have discussed about the Gauss transformation of equations. We have discussed. And now the target of this unit 2 is what how the electromagnetic waves are going to interact with the surroundings of different areas and how it is going to work. Let us try to know here point by point. Here is EM waves, electromagnetic waves. What is specialty of electromagnetic waves? It is traveling with the velocity of light mu naught by epsilon. So if you substitute the mu naught and epsilon naught, the value is how much? It is equal to 3 into 10 power 8 meter per second. Understand? So what will happen if you substitute mu naught equal to 4 pi into 10 power minus 7 centimeter per cubes? Like that we are having. Epsilon naught is nothing but what? 8.85 into 10 power minus 21 nearly centimeter meters. Will happen if you substitute This values in this we are getting nearly 3 into 10 power 8 meters per second the light can travel. So what we have concluded here, the electromagnetic waves which are traveling in the free space. Free space means we are having the no vacuum but entirely matter. We can call it a matter of this type. So we can able to know that EM wave is also what one EM wave is also a equal to the what is equal to the light. Like that we can able to understand. So if you try to see the earth surface like this, we are having entire surface. Whenever the radio waves are the different types, the radio waves and the large ribbon. Hmm? So whenever the waves are traveling from one form, it is going to interact with the different layer. We have the three layers. Ionosphere we are having. In ionosphere, what will happen? We are having the different molecules. Different molecules. They are trying to interact with this and coming later. What happens? Another molecules, if you are trying to take, it does not drive it. If the charged particles are there, electrons are there, what will happen? Whenever the electrons are there in the ionosphere, try to interact with the radio waves and dipole moment changes like spectroscopy. Secondary we are having, and we are giving the reflection or reflections of rays. Like that, in entire free space, the light can travel up to the 3 into 10 power 8 meters per second. That is the principle based on what it is entirely. The principle is based on the electromagnetic waves in the free space. Free space means what? There is no obstacles, but obstacles in terms of what? Free obstacles in terms of ions and molecules and atoms. Put together, we are going to get the electromagnetic wave. How it is going to travel in the free space. So, what is isotropic? Isotropic or homogeneous? Isotropic means wherever we are trying to take, all the structural arrangement of the molecules will remain same. All the structural arrangement of the molecule will remain same. There will be no change. If same radio waves you're trying to send in place of radio waves, if you're trying to send another waves, then what will happen? It does not able to touch to the Earth surface, and most Earth surface are in the ionosphere. Does not able to touch. What will happen? Then you cannot able to get the reflected image because it is getting absorbed. What is our target here? That the wave should be go to the surface and should come back in the medium. Then a calculator with the free space, the velocity is 3 into 10 power 8 meter per second. We try to know step by step what actually the free space is going to travel. What actually when we are having isotropic homogeneous. Homogeneous means wherever we are having the molecules will be same. No difference. Heterogeneous means different molecule layers we are having. So I will try to explain now the more details in the derivation part of the isotropic homogeneous medium of a free space. Or simply in exam they will ask how the electromagnetic waves are going to travel in the free space. It's a fundamental thing we should try to. Let us discuss now. So orally in this today class, we have what we have learned. We have learned that how the electromagnetic waves are going to propagate from one medium to the another medium. Understood? In which medium we are only permitted to discuss the electromagnetic wave propagation in free space. Free space means what? Nothing but vacuum. Vacuum doesn't mean we don't have any molecules or particles. Definitely, we are going to have the molecules and particles. Orally, in this class, we are able to understand that light velocity is nothing but equal to the electromagnetic wave. Light is nothing but itself is a two components. We have drawn the diagram also in the starting and ending of the lecture. We discussed C is equal to 1 by under root epsilon naught by mu naught equal to 3 into 10 power 8 meters per second. That's what. Understood. Like that, we can able to understand how the wave is going to behave the wave space. So, orally in this class, we have discussed about the EM spectrum. Starting, we have discussed about the EM spectrum. Next, what we have discussed, what is different range of wavelength we have discussed. Along with that, we have discussed the components of wave. and E and B, electric field and magnetic field, component fields, component fields enabled. And after that, what we have discussed, we also discussed about the EM spectrum, components, E and B component fields. And last, we have proved that C is equal to 1 by under root U naught epsilon naught. C is equal to 3 into 8 or 8 meter per second. When the wave is going to travel from in the free space of the model. When you start interacting with the ions, definitely it should be equal to this kind. So this is about our today class. This class will discuss about the another topic of isotropic or diagonal.